Okay, so here is the code that I have done to do the exercise. And in this case, I have not used any interrupts. Okay, so uh, remember the code that we used before for ADC, where we took a value that is coming from the ADC and printing it onto the serial port. I've just used the same code and I've just modified it a bit here and there. Okay. The one thing that you would have to modify is that you would have to set this pin 12 to an output, right? Because right now, uh, in the ADC program, there is no output here. Now, how do I do that? So I go to this table that I have. Oh, I'm sorry. So this table that I have, and in this table, you can see that digital pin 12 is same as PB4. Okay, so I need that information. And once I have that, what I can do is I can set my data direction register, the fourth bit of the data direction register, to 1 because I want it as an output. So that is 0, 1, 2, 3, 4. So I set the fourth bit here as 1. Okay, and I put this in a function called init IO ports. So basically initializing IO ports, and I call that function here. So basically this command, I could have directly written that command here instead of putting it in a function, but I just like to put it in a function because if there were more initializations that you want to do, you can put a huge line of like 10 lines here and still your main program remains readable. Okay, so I initialize my IO ports. That is, I made this pin 12 of my Arduino board to be an output. And now what I do is I simply say if ADC value is greater than 512, so all these were already there in the ADC program. I just said if ADC value is greater than 512, write a 1 at bit 4. Okay, so that's the fourth bit of port B. If not, else write a 0 at that location. Okay, very straightforward. So let's run this code now. So I'm going to start the simulation. So you can see that the value here is 3.10, which is greater than 2.5, and therefore the LED is on. Well, in terms of the LED, I should just mention that I've changed the resistance of here to 100 ohms just so that the LED can glow a little brighter. Now let me bring this down to some smaller value. So that's 1.10, and you can see that the LED is off. Let's go a little bit higher. So 1.80, the LED is still off. What's the value now? 2.10, the LED is still off. 2.40, the LED is off. 2.50, the LED is off. Little up, and hopefully the LED turns on. Yes, the LED turns on. So that's my program is working.